This is the notes for 2.6 absolute value functions. Question 1 asks us to write the domain and range in interval notation. To do this, we have to know whether we're going to use a bracket or a parenthesis. If we have an open dot, it's a parenthesis. A closed dot, we use a bracket. So the first thing we need to do here is find what our points are. This point is at -3, +2. This point is at 3, -2. So now our domain, which we know is our x values, are -3, +3. So we want to write those in numerical order, lowest to highest. So we get -3, +3. Okay, the -3 comes from a closed dot, therefore we use a bracket. The +3 comes from an open dot, therefore we use a parenthesis. Now for the range. Range, of course, is our y values. So our y values are 2 and -2. Again, we want to put these in numerical order, lowest to highest, so -2, 2. The 2 comes from an open dot, or the -2 rather comes from an open dot, therefore we use a parenthesis. The 2 comes from a closed dot, so we use a bracket. Questions 2 through 4 are all asking you to graph absolute value functions. Absolute values should always form either a V or an upside down V. So if we look at our first question, question 2, we need to get 3 points. In this case, our x is the only thing inside the absolute value symbol. When that happens, we have a center x of 0, and then we just take one spot to the left and to the right of 0 for our other 2 points. So that would be -1, 1. To get our y's, we simply plug in our points. If we plug in 0, we'd get -3 times the absolute value of 0, which is -3 times 0, which is 0. If we then plug in -1, we get y equals -3 times the absolute value of -1. So this becomes -3 times 1, which is -3. Now, by rule, these two y's will have the same value. So now we simply plot our 3 points. Once we have our 3 points plotted, we can connect them to either get a V or an upside down V, connecting each one of these points to the center point. So here we see that we have an upside down V. Question 3. Okay, again, our x is the only thing inside the absolute value symbol, so our center x is 0. We go 1 to each side of it to get -1 and 1. So now if we solve for our y's, if we plug in the 0, we're going to get 5 times the absolute value of 0 minus 7. This, of course, becomes 5 times 0 minus 7, which will give us negative 7. If we plug in the negative 1, we get y equals 5, absolute value of negative 1 minus 7, which gives us 5 times 1 minus 7, which, of course, will become negative 2. So this one's negative 2, therefore this one is negative 2. Again, we plot our 3 points. And again, once we plot our points, we connect each one of our outside points to our inside point. And as you see, we come up with a V. The final question is a bit different. Notice that this time we have something other than just X inside of our absolute value symbol. When that happens, you take whatever's inside of your absolute value symbol and you set it equal to 0. And when you solve it, it'll tell you what your center X should be. So here we have X minus 5 equals 0. So we know we would add 5 to both sides. And doing so, we would get X equals 5. Therefore, our center X would be at 5. And just like we did with the other ones, we go 1 to both the left and right of our center point to get our other two X's. So this would give us 4 and 6. So now to get our Y's, we just plug it in. So if I want to figure out what my Y is for 5, I get negative 4, absolute value of 5 minus 5, plus 3. Okay, so this will give me negative 4 times 0 plus 3, which of course gives me 3. Then, if I want to figure out what it is when I have 4, I get Y equals negative 4, absolute value of 4 minus 5, plus 3. This will become negative 4, absolute value of negative 1, plus 3. That will then become negative 4 times 1 plus 3 to give me a final answer of negative 1. Therefore, my Y when X is 4 is negative 1. And then I know this point would also be negative 1. So now as I graph my 3 points, okay, I got my 3 points graphed. And again, once I have my 3 points graphed, I just connect them to get my V shape, in this case an upside down V. So that is the notes for 2.6 absolute value functions.